Hello, my name is Surya. I am a chemistry lecturer. I have an experience of 20 years in IIT, NEET and JEE and advanced also. Now I will take a class in electrochemistry. Okay. So what is electrochemistry? It is a branch of science which deals with the electricity and chemistry. That is the basic definition of electrochemistry. Now in electrochemistry, first I define the electrolysis. What is electrolysis? The splitting of an electrolyte by sending of electric current through it is called electrolysis. Okay. So I will discuss the electrolysis with one example, because in electrolysis concept it may be question from 8 and JE. This topic is covered. One question is there. It will be chance is there in NEET examination, mains examination. That is. So I will explain the electrolysis with one example. I will take a fused NaCl. Fused NaCl. Fused NaCl means a salt is heated, then it is molten. That state is called fused or molten NaCl. So there is no water is present. So in this electrolysis, one electrolytic cell is required, and powdered NaCl is heated, then it is melted. So NaCl is all NaCl particles are molten state and the molten state. That is Na plus and Cl minus. So two rods dipped into the solution. That is a positive rod and a negative rod. Positive rod and negative rod. Negative rod is called cathode. Positive rod is called anode. So these two are connected with the battery. So negative rod is called cathode. Positive rod is called anode. So I will explain what is the phenomenon of electrolysis for example. So if we take an NaCl, it is a fused state. During electrolysis, what happens? In the process of electrolysis, this is an electrolysis. It split into Na plus and Cl minus. Na plus and Cl minus. Here there are two rods are there. One is cathode, other one is anode. What happens? After splitting of NaCl, positive ions travels towards negative rod. Negative ions travels towards positive rod. So I will write in bold. So at the cathode, that means NaCl is gives rise to Na plus and Cl minus, and at the anode, 2Cl minus is gives rise to Cl2 plus E minus. That is at cathode, 2 NaCl. Generally 2 NaCl is split into 2 Na plus and 2 Cl minus. At cathode 2 Na plus, but gaining of 2 electrons is converted into sodium. At anode 2 Cl minus gives rise to Cl2 plus E. Here cathode it undergoes reduction. At anode chlorine evolved anode, so it undergoes oxidation. This is the reduction product, this is the oxidation product. This is the simple electrolysis, but it is not this type of questions not in the examination, but another type of given to mains and NEET and examinations, that is I will explain. So this is the phenomena of NaCl. NaCl is gives rise to Na plus and Cl minus. Here sodium deposit cathode, chlorine evolved anode. This is the general theory. Everybody know it. But This type of question is not asked in mains and examination, but theory is same. So I will take another one. I will take aqueous NaCl. In the previous case, I take fused NaCl, but in this state, I will take aqueous NaCl. What is the difference between aqueous NaCl and fused NaCl? So, what is the meaning of aqueous and fused? In fused, there is no water. Only two ions are present. That is Na plus and Cl minus. In this case, is very important. In aqueous Cl, I will take aqueous NaCl. Same phenomena. So, aqueous NaCl means only aqueous NaCl means water dissolved in NaCl or NaCl dissolved in water. So, in the previous case, only without water. It is with water. So that means aqueous NaCl. That means same vessel is taken. NaCl powder is taken. Na plus and Cl minus. Water is filled in it. Completely filled in it water. So positive rod and negative rod. Negative rod and it is a positive rod. It is same phenomenon. It is cathode. It is anode. Two are connected with battery. Aqueous NaCl. Two are connected with battery. So in this case, during the process of electrolysis, first of all, 2 NaCl gives rise to 2 Na plus and 2 Cl minus. Same like that of fused NaCl. But in this case, it is aqueous. This is very important. So aqueous means what along with NaCl. So water is there. You know that water is electrolyte. And in place of electric current, it is split into two ions, H plus and OH minus ion. H plus and OH minus ion. So in this case, there are two cations are there. There are two anions are there. So in mains examination or NEET examination, which product evolved better in the electrolysis of aqueous NaCl? So we have one doubt, that is Na plus H plus. Two ions are there. Which ion will be deposited cathode? So this type of NaCl, aqueous NaCl salts, not NaCl, any type of aqueous salts depends upon the follow the discharge preferential theory. So what is discharge preferential theory? In an ion having lowest discharge potential deposited first. That is called discharge preferential theory. Okay. So we want to know about which product is evolved cathode, which product evolved anode. But this is followed by discharge preferential theory. But fused NaCl, there is no required, only two ions are there, Na plus and Cl minus. So when deposit cathode, don't evolve simply. But in this type salt, we have a doubt. Two cations are there, two anions are there. So what is the discharge preferential theory? If you take both cation and anion, an ion having lowest discharge potential will be deposited first. How to know which is lowest, which is high? Then we have an order of anions. What is the order of anions? I will write order of anions. Order of anions. We have generally OH minus is the anion and fluoride is there, it is anion. Next sulfate is there. Next NO3 minus is there. So all this type of ions, fluoride, nitrate, sulfate, OH minus. Next one is Cl minus, Br minus, I minus. This is the order of anions. So you see, this is the order of anions according to discharge preferential theory. What is the discharge preferential theory? In an ion, we have two ions. For example, this is NaCl, Cl minus and OH minus. Two anions are there. Two anions are there. So we have to see this series Cl minus and OH minus. So here Cl minus and OH minus. Cl minus is there, OH minus is there. Which is the lowest discharge potential? Definitely chlorine has lowest discharge potential. So chlorine is evolved first compared to the OH minus. So according to this theory, what is the reactions of anode? At anode. That is 2Cl minus is gives rise to Cl2 plus 2E minus. So according to this theory, chlorine is evolved at anode. According to which theory? Discharge preferential theory. I repeat again, this is very important. What is the discharge preferential theory? An ion having lowest discharge potential will be deposited first. Among these anions, we have two chloride ions, one OH minus ion. So according to this, we verify the theory. Chloride is highest potential, sulfate highest potential, nitrate highest potential. OH minus is better than considerable potential. So all halogens except fluoride, all halogens are less discharge potential as compared to OH minus. So in the electrons of aqueous NaCl, chlorine is evolved. This is the concept of deposit of ions. Okay. Now then we'll go cation. Same theory, cation. What is the discharge preferential theory? If the solution contains two cations, an ion having lowest discharge potential will be deposited first. Yes. So this is the serial. We learn about H plus, all cations. H plus is a H plus ion. There are divided into two parts. It is very easy. The series is divide H plus is the central atom, central ion. Below H plus are only 4 cations are there. That is Cu plus 2. That is Ag plus. That is Au plus 3. That is Hg plus 2. So below hydrogen, copper, silver, gold, mercury. Above hydrogen, all first year group elements. For example, Li plus, next Na plus, K plus, and the next one Mg plus 2, just Zn plus 2, and so on. No, so many ions are there. But we remembered very simply, because H plus, if the ion having greater than H plus ion, hydrogen will be deposited. If the ion having less than H plus ions, any of the 4 ions will be deposited. Very simply, I repeat again, in cation series, only 4 cations are less potential compared to hydrogen. What are that? Copper, silver, gold, mercury. So, for example, how to identify the 2 cations? So, 2 cations are there. That is 2Na plus H plus. So, you know the series. That 4 ions. What are the 4 ions? Cu plus 2, Ag plus 2, Ag plus, Au plus 3, Hg plus T. So, there is no copper. There is no silver. There is no gold. But Na all first A group. Here simple trick is there. All first A group, second A group. Some of the D block elements are above H plus. Only 4 ions are. What are that? Cu plus 2, Ag plus, Au plus 3, and Hg plus T. These ions are less discharge potential as compared to hydrogen. So Na plus and H plus, which ion will be deposited? Simply we can say hydrogen will be deposited. Hydrogen gas is evolved. What is the reaction? At cathode. At cathode, that is 2H plus and 2E minus. This gives rise to H2, hydrogen gas. This is the, so hydrogen gas evolved at cathode. So in the presence of in the electrons of aqueous NaCl, hydrogen gas is liberated at cathode. At anode, 2Cl minus gives rise to Cl2 plus 2 electrons. chlorine gas is evolved. But in case of usually NaCl, it is very different. In that case, sodium will be deposited. So in this concept, there is a chance for the give you a question for mains examination or NEET examination. Okay. So I will explain with one example. This type of question for very very important for mains and NEET examination. For example, I will explain one example. CuSO4 copper sulfate in aqueous state. In the electrolysis of copper sulfate, which product is formed at anode and cathode? That is the asking question. That is aqueous copper sulfate. So you can see what is the theory? CuSO4 is split into Cu plus 2 plus SO4 minus 2 normally, but it is aqueous state. Aqueous state means with water. So along with water, copper sulfate is there. H2O gives rise to H plus and OH minus. What is the question? Which ion is evolved and which ion is deposited cathode? Which ion is evolved anode? So we have two categories. According to discharge preferential theory, an ion having lowest discharge potential will be deposited. Already previously I told that copper ion and H plus ion. Which ion has the lowest discharge potential? Definitely copper. So at cathode, that is Cu plus 2 plus 2E minus gives rise to copper. At anode, 2H plus 2E minus gives rise to hydrogen. Here this is 2H2O, it is 4H plus, that is also there. So hydrogen gas is evolved at cathode. No, one minute. At cathode, copper is deposited at cathode. Here at anode, there are two ions are there, sulfate ion and OH minus ion. You know that sulfate ion is always greater than that of OH minus ion. So OH minus will be deposited anode. Why? How to find the OH minus? Because of 4 OH minus are converted into 2 water molecules and liberation of hydrogen. So in the electrolysis of aqueous copper sulfate, 2 ions are 2 metal, one and a copper metal deposit cathode and hydrogen gas evolved at anode. This is the concept of electrolysis. This type of question is very very important for NEET at JEE and NEET. Okay. I will ask another question with one example. What the product obtained in aqueous AgNO3? Here it is aqueous. That is very very important. Aqueous means AgNO3 gives rise to Ag plus NO3 minus. Okay. Next, water is there. H2O gives rise to H plus and OH minus. Okay. We have two anions are there. According to discharge preferential theory, NO3 minus is always greater than OH minus. So OH will be deposited. So at anode, that is 4 OH minus gives rise to 2H2O. plus liberate of 4 electrons. And at cathode, Cu plus 2 electrons, this gives rise to copper. So copper deposited cathode, not copper, sorry, is the silver is there, sorry, silver. Ag plus. So Ag plus E minus gives rise to silver. So silver is deposited cathode and H2O, 4H minus plus equilibrium of oxygen gas. This is the electrolysis concept. Okay. Next, I will explain the Faraday's laws of electrons. Faraday's laws of electrons. There are two laws are there, that is Faraday's first law and Faraday's second law. Now I can define first law. First law. What is the first law? The amount of substance deposited at an electrolyte at an electrode is directly proportional to the quantity of electricity. It is called Faraday's first law. I repeat again. What is Faraday's first law? The amount of substance deposited at an electrode is directly proportional to the quantity of electricity passes through it. That means I will take a vessel. Same, I will take another any electrolyte, KCl I will take. Two electrodes are there, cathode and anode. So what is the first law? If the current is passed through electrolyte, potassium will be deposited. How much deposited? How much will be current is passed? That amount directly proportional to the quantity of electricity. So mathematically, the amount of substance deposited in electrode is directly proportional to the quantity of electricity. That means W proportional to Q. That means according to Faraday's first law, mathematically, you can derive an equation, this formula, W proportional to Q. Q means current in coulombs. Okay, that equal to W equal to Q means C into T. This is proportional. C equal to current in amperes, T equal to time in seconds. That is which is equal to E into C into T. Here is very important. E is called electrochemical equivalent. Electrochemical equivalent. That is very important. So what is the definition of electrochemical equivalent? Same phenomenon. For example, one electrolyte is taken. What is the definition of electrochemical equivalent? If the C equal to 1 and T equal to 1, then W equal to E. This is called definition of electrochemical equivalent. So how it is saying as a definition, if the 1 ampere of current, 1 ampere for the same electrolytes, negative and positive, battery connected, KCl is there. If 1 ampere of current passes through electrolyte with 1 second, some amount of, definitely some amount of salt deposited, some amount of potassium deposited. How much amount of deposited? That is called electrochemical equivalent. I repeat again a definition. What is electrochemical equivalent? If 1 ampere of current is passed through 1 second, the amount of substance deposited electrode is called electrochemical equivalent. It is very important. Okay. Next, I will define another one. chemical equivalent. What is the chemical equivalent? Here, small e means electrochemical equivalent. It is a only chemical equivalent, that is capital E. I repeat again, small e and capital E. Small e means electrochemical equivalent. Capital E means chemical equivalent. So, what is the chemical equivalent? If 1 Faraday of electricity is passes through electrolyte, the amount of substance will be deposited at electrode. That is called chemical equivalent. Electrochemical equivalent and chemical equivalent. Then we have relation between E and capital E and small e. Capital E and small e. So that is relation means what relation? Relation between small e and capital E. What the relation? Small e equal to E by F. This is the relation between small e and capital E. Here small e means electrochemical equivalent. Capital E means chemical equivalent. F means Faraday. You know that Faraday equal to how many coulombs? 1 Faraday equal to 96,500 coulombs. That is important. So this value substitute in the place of E. That is equal to W equal to capital E by F into C into T. Okay. E means chemical equivalent. F means Faraday. C means current in coulombs. T equal to time in seconds. Finally, W equal to E C T by F. That is a derivation. But one step is there. Another step is there. That is E means chemical equivalent. That means equivalent weight. Equivalent weight means molecular weight by its valency. So I can write E means molecular weight by Z. M means molecular weight. Z is valency. That is called E. C equal to current in amperes. T equal to time in seconds. And F. F means what is the value? 96,500 coulombs. So this is the formula for first law of thermodynamics. Some problems are given based on this concept. Okay, this is the Faraday's first law of thermodynamics. Next. Faraday's second law. It's very easy. I will take 3 different vessels. First vessel, second vessel, and third vessel. First vessel I will take NaCl. Second vessel MgCl2. Third vessel AlCl3. So it contains 2 rods. It is anode, it is cathode. Same, it is cathode, it is anode. Next, it is anode, it is cathode. So, all are connected with battery. That means it is a positive, it is a negative. So, these 2 are connected with the battery. So, this one. Next, this is the connected. This is the connected. Okay? So, it is NaCl, it is MgCl2, it is AlCl. Okay? So, what is the Faraday's second law? If the same quantity of electricity passes through 3 different electrolytes which are connected in a series, the amount of substance deposited electrode are in the ratio of their equivalent weights. I repeat again. What is the second law? If the same quantity of electricity is passes through different electrolytes which are connected in a series, the amount of substance deposited electrode are in the ratio of in their equivalent rates. That means W of Na plus that Na is to W of Mg is to W of Al, which is equal to equivalent weight of sodium is to equivalent weight of magnesium is to equivalent weight of aluminum. This is the second law of Faraday and Faraday's second law, which is equal to this is enough for the second law. This is the concept of second law of electrolysis. Clear? Okay.